On Summarize Science, let's delve into a fascinating research paper where scientists are exploring how to teach robots to mimic human actions by watching AI-generated videos. The central idea is that video generation models are becoming increasingly adept at creating human actions in diverse settings, making them potential high-level planners for robot control. But how can a humanoid actually perform these actions from the videos without direct training? The challenge lies in the noise and morphological inaccuracies often found in generated videos. To tackle this, the researchers introduce a two-stage pipeline. First, they use existing models to convert the video into a 4D human motion trajectory. Then, they retarget this trajectory to fit the robot's body shape. The second stage involves a physics-aware reinforcement learning policy called GenMimic, trained to use 3D key points to control the robot's joints. GenMimic incorporates symmetry regularization and weighted keypoint tracking to improve robustness. This means the robot focuses on important key points and uses symmetry to correct errors. A synthetic dataset called GenMimic Bench, created using two video generation models, tests the robot's zero-shot generalization and policy robustness. The results show that GenMimic outperforms strong baselines in simulation and can even perform coherent motion tracking on a real Unitree G1 robot without fine-tuning. Looking at Figure 3 on page 5, we can see how the GenMimic policy works in training and testing. During training, there are rewards weighted key points so the robot knows what to focus on and a symmetry loss. In tests, you see how the robot can mimic the actions from these AI-generated videos. The results are impressive. Now, turn to Table 1 on page 7 to check out the details of the simulated experiments against other systems like GMT and Twist. The key here is that the SR metric, or success rate, goes up quite a bit higher compared to the other robots. This shows that GenMimic is much better at carrying out a task than the others, at 86.77%. Also, MPKP is mean per key point position error, and a lower number is better because it is the error. You can see that GenMimic gets this pretty low, too, meaning that it doesn't have issues with getting the location of things. Overall, GenMimic represents a significant step towards enabling robots to learn from video generation models. The two-stage pipeline and robust policy design make it possible for humanoids to perform actions from noisy, synthetic videos in a zero-shot manner. This opens the door for video generation models to serve as high-level policies for robot control, revolutionizing the way robots learn and adapt to new tasks. Imagine a future where robots can quickly learn complex tasks by simply watching AI-generated videos, leading to more versatile and adaptable machines in our daily lives.